Okay, quadratic formula. I know you've heard of it before, probably used it a little bit. I even condensed this a little bit, but there's a fair number of SOLs that relate to the quadratic formula. The number one of which we're going to show, we're going to derive the quadratic formula by using completing the square process. That's an SOL. It's kind of worded like this. Students should recognize that the quadratic formula can be derived. Yeah, it doesn't say you have to do it. It says you have to recognize it. I've never seen any test question that had anything to do with, knowing this thing right here, but that is the SOL. And, the next one is essentially you should know how to choose an appropriate method to solve a quadratic equation. Really, there are some methods that don't always work. Like you can't always factor everything. So you can't say solve by factoring and know that it'll work all the time. That would be a wrong choice. You can't solve by graphing all the time because, what do you look for when you solve for graphing? You look for the x-intercepts. What if there aren't any x-intercepts, right? So that wouldn't be an appropriate method to use. But the quadratic formula always works. So essentially, this is your appropriate strategy all the time. I think I told you before, when I was your age learning this stuff, if we couldn't factor it really easily, then we just use quadratic formula. And then this last thing probably doesn't make much sense now, but when we finish, it will. And it won't be hard at all. So first thing we're going to look at is this is the standard form of a quadratic equation. Standard form equals 0. It's where most of our methods start. Factoring starts there, graphing starts there, quadratic formula starts there. Do you remember the completing the square process? If A is anything other than 1, what are you supposed to do? Factor it out, right? Factor it out of the first two terms. So the first step here is first we'll move the constant to the other side. We did that with completing the square. And then we're going to factor A from these two terms. That looks like this. A times, A times x squared plus B over AX equals negative C. So where's the B over A come from? If you're dividing out an A from B, then you get B over A. And if you're not sure about that, just go backwards. What is A times B over A? The A's cancel and you get B. Okay, so that is the way it works. Okay, now what's the process to complete the square? Now that we have a 1 in front of the x squared, what do we usually do to find the number that goes here? Yeah. Half of the middle coefficient squared. Okay, well, what's half of B over A? It's B over 2A, right? So B over 2A is half of B over A. And when you square it, you get B squared over 4A squared. So that's what we have to add to complete the square. Plus B squared over 4A squared. Now remember, when you have something outside parentheses, that means that we are not going to just add this to the other side. We have to take into account that it's being multiplied by something. So what are we actually going to add to the other side to balance what we did? A times B squared over 4A squared. How does that simplify? This A cancels one of these A's. So it's just B squared over 4A. Right, so I'm going to make myself some room here. Right, so we add plus b squared over 4a. Okay, now that gives us a perfect square trinomial, which is x plus b over 2a squared equals, and I'm going to switch sides here, b squared over 4a minus c. Okay, now, how could I combine the two terms on the right? What do I need before I can combine those? One's a fraction with a denominator, the other one has a denominator of 1. I need a common denominator. So what will I multiply here? 4a, right? So 4a over 4a is going to be b squared minus 4ac is in the numerator, and it's divided by 4a. Okay, now, before we can take the square root of both sides, we have to divide by a. So that'll gonna go there. Make that a square. Yeah. What's that? How do you take that out?
Like, how'd you get from the top one?
From here to here?
From the first one to the second one. Yeah.
You know, normally when we do the completing the square, right, once we've added the right thing there, then we know that we just created a perfect square trinomial, and it'll be x plus or minus something in parentheses squared. The something is always the half of the middle term. So the half of b over a was b over 2a. So I'm just writing that as the perfect square trinomial. I mean, you could FOIL that now, and it would be this exactly. Right. So then we divide. Now we have x plus b over 2a squared equals b squared minus 4ac divided by 4a squared. So we've solved for the squared term. We're ready to take the square root of both sides. Right? So it's square root. X plus b over 2a equals, and now when I take the square root, here it's going to be b squared minus 4ac divided by 4a squared. But the truth is, we can simplify that denominator. What's the square root of 4a squared? 2a, right? So actually, that part can simplify. That will look like the square root of b squared minus 4ac divided by 2a. So we're almost done. We just have to subtract this to the other side. X equals negative b over 2a plus or minus, I should have put a plus or minus there, plus or minus the square root of b squared minus 4ac, and that's divided by 2a. And since they're both divided by 2a, we usually just draw one fraction bar. Right? And that is the quadratic formula. I'm going to write it over here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just putting it there so that later if I want to just have it where I see it. I mean, that's how you derive the quadratic formula. And it's, you know, really Algebra 2 level math, basically. And yet it leads to something that is so useful. Okay, there you go, quadratic formula. Okay, it depends on that you started with a standard form quadratic equals 0, right? And then based on that, you use this formula to solve for x. Right? All you need to find is what are the values of a, b, and c, and you plug it in. I mean, at that point, it's like a mechanical process that, you know, you don't even have to understand very much. And you're given the quadratic formula on the SOL. So you don't have to remember it. You just have to know how to plug things in. Be relatively okay with that. Okay, we're ready? Still going? Sarah? Okay. So this example, I've just used the book example because, you know, it's color-coded, shows where everything goes. You know, they started with an equation which was not set equal to 0. So you can see the first step, they had to subtract 2 from both sides. You would have to do the same thing, right? It has to be standard form equals 0. And remember, standard form means the squared term and then the linear term and then the constant term. I mean, that's how you get the A, B, and the C. Right. In this problem here, what is the value of A? In this thing right here, what is the value of A? Right. A is the coefficient of the x squared term, so A equals 1. Right. And B is 3, and C is negative 2. Okay. When you're plugging into the quadratic formula, don't also put the x in there. The x is not part of it, right? It's just those numbers. Okay. At that point, you just plug them in. That's all they've done from this line to this line. They're putting in 3's in the place of B. They put in a 1 in the place of A, and they put a negative 2 in the place of C. And that's simplification. They didn't show it, but 3 squared minus 4 times 1 times negative 2. The negative times a negative makes it a plus. So that's 9 plus 8, 17. Can you simplify that anymore? Can you simplify the square root of 17? It's a prime number. No, you can't simplify it. That's it. Done. That is the way usually you'll see the answers, right? They would not turn that into a decimal. That's the way you'd be looking for the answer. So what kind of number solutions are these? What sets of numbers does that come from? What's that? Is it real or imaginary? It's real because there's no I, right? It's actually irrational because it's got an unsimplified square root. Okay. What is the fact that it's real? What is the fact that it's irrational means it cannot be put in the form of a fraction, right? These numbers can't be. If it can be put in the form of a fraction, that tells you that actually it's factorable. You could have solved it by factoring. If you would have just thought of it, it would have worked, right? But if it's irrational, that means you were never going to solve this by any other method, except, well, you could have solved it with a calculator, graphing with a calculator. I'm going to do this example before I got it like this example, and then you get a couple you tries. So what do I need to do to this one before I try plugging things into the quadratic formula? It needs to all be set equal to 0. So I'm going to subtract 12x and add 9 to both sides. So now I have 25x squared minus 30x plus 9 equals 0. Right, what is the value of A? What is the value of B? What is the value of C? A equals 25. B equals negative 30. C equals 9. So put all that into the quadratic formula. Right? It'll look like this. X equals negative 30 plus or minus the square root of negative 30 squared. minus 4 times 25 times 9. That's over 2 times 25. Right, x equals 30 plus or minus. Right, what is negative 30 squared? Say again? It's positive 900, right? Common mistake is somehow you square a negative and you got a negative, right? That's going to get you on the wrong track. Negative 30 times negative 30 is positive 900. And then what is 4 times 25 times 9? 900. So this is 900 minus 900 divided by 50. Okay, well that means x equals 30 plus or minus the square root of 0. But the square root of 0 is 0. So this actually, what it means is that we're going to get the same answer whether or not we add or subtract 0, 30 over 50, or 3/5. Okay, if we were factoring that, what kind of factoring would we have done in that? It's a perfect square trinomial. Remember, that's the one where you get something in parentheses squared equals 0, so you only get the one solution. Okay, well in the quadratic formula, that's what it looked like. I mean, we could have factored that by doing 5x minus 3, minus because that's a minus. 5x minus 3 squared. Right? And then if you set 5x minus 3 equals 0 and solve 3/5. That's it. So those two are telling you the kind of real solutions you get. You either get two distinct ones because there was something that came out of the square root and it was positive square root, or you get one real solution because actually what was inside the square root was 0. So you try those two. What do we have to do first on the second one? Get everything on one side, 0 on the other. And I'm just going to do it without showing. 4x squared minus 12x plus 9. And so our x is negative 12 plus or minus the square root of negative 12 squared minus 4 times 4 times 9 divided by 2 times 4. So x equals 12 plus or minus the square root of 144, and 4 times 9 is 144 divided by 8. So this is 12 plus or minus the square root of 0. So we just get one answer repeated. Because what kind of factoring would we have done if we actually were factoring this? Perfect square trinomial. That's why you get that answer. Perfect square trinomial, right? You'd say that's 2x minus 3 squared. Okay? Now, I'm going to do another one. Again, I need to get everything on one side and 0 on the other. And I could subtract 5. And you know, it makes less difference here than it does when you're factoring to have a leading coefficient, which is negative. But I would still prefer to have positive. I mean, personally, not only to have a leading coefficient, which is positive, but just in terms of, if I move the 5 over here, now 2 of my terms are negative and 1 is positive. If I move these over here, 2 of my terms are positive and 1 is negative. And just, negative signs are the source of most of our issues when we do calculations. So I'm going to actually add x squared and subtract 4x to get onto the other side. You don't have to. You could do it the other way. It'll all work out the same in the end. So this will be x squared minus 4x plus 5 equals 0. So x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 5. All over 2 times 1. X equals positive 4 plus or minus the square root of 16 minus 20 divided by 2. So x equals 4 plus or minus the square root of negative 4 over 2. All right, now what kind of solutions am I going to get? Taking the square root of a negative, what kind of numbers are going to be they're going to be imaginary, okay? So this is 4 plus or minus 2i divided by 2, which is 2 plus or minus I. So generally speaking, those are the 3 possibilities, right, with those 3 examples. You get 2 real, you get 1 real, or you get 2 imaginary. Priyashi, okay? Anybody? Emily? Michelle? Everybody? Okay. So you try that one. Again, you can get these all on one side, either by putting them on the right or on the left. I'm going to get them on the right so I have more positives than negatives. I think that works out. Right, so I'm going to subtract 7x, add 5x squared, and add 4. So I got a positive 5x squared to lead the way. I have a negative 5x, and it looks like I got a plus 7. And I'm sure that's right. Okay, so now I plug in the formula. X equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 5 times 7. 2 times 5. X equals 5 plus or minus the square root of 25 minus 4 times 5 times 7 is 140. So x equals 5 plus or minus the square root of negative 115, which is 5 plus or minus I times the square root of 115. Now, Can you simplify the square root of 115? No. I mean, it's 5 times 23. That's as far as it goes, right? Can you cancel 5 into 10? No. Remember, you cannot cancel unless you've got factors of the denominator and factors of the whole numerator, not just one term. I mean, what about, why not cancel a 5 here with a 5 there? Because that's inside the square root. You can't cancel factors that are inside the square root with factors that are outside the square root. So you could write this as two terms. You could write it as 5 over 10 plus or minus I root 15 over 10, and then the 5 over 10 would be a half. I'm sure that's the way the book would have it. Yes, you would have gotten the same answer. You would have ended up, that would have been a positive, but that would have been a negative. And that would be squared. It's the same sign anyways. And then I think both of those turn negative. So it all, in the end, it all works out. All right, so that is, we did one of each. We're only doing 4 examples today, right? We did 2 real, 1 real, 2 imaginary. Now we're talking about a particular part of the quadratic formula, which is just what's underneath the radical. Because in the end, what is it that determines whether or not we get real or imaginary solutions? Whether or not you're taking the square root of a positive or a negative. That's it. It all comes down to what's the value of b squared minus 4ac. And that has a name to it, right? It's called the discriminant. Right? The discriminant is b squared minus 4ac. Does not include the radical itself, right? So don't take the square root of it. Just we'll be calculating b squared minus 4ac. Good? So I showed you this before, but I didn't have the discriminant on the top. I only copied the part that was below. But now we know by what's inside the radical, by the b squared minus 4ac, we know how many and what kind of solutions we expect. Right? If what's inside the square root is positive, greater than 0, then when you take the square root, you get a positive real number. And when you do plus or minus, you get two different real numbers. Right? So that's what it looks like when the discriminant is greater than 0. Right? The function would cross the x-axis twice. When the b squared minus 4ac equals 0, now you're taking the square root of 0, which is 0, which means the plus and the minus don't make any difference. So it means that the graph of the function would just touch the x-axis, but go back on the same side. So you get one distinct real solution. If what's inside the discriminant is less than 0, then you're taking the square root of a negative number. So you would expect 2 imaginary solutions. You would expect that the function graph doesn't cross the x-axis. It's either above opening up or below opening down, but it doesn't cross the x-axis. Ethan, you done? Okay. So I'm going to do these three and then I'll give you a you try. Right? These questions are always worded the same way. It says, find the discriminant. Means calculate the b squared minus 4ac. And then answer the question, how many and what kind of solutions do you expect? Right? So you always have to do both parts. Don't just do one part, do both parts. So again, we're doing the discriminant is b squared minus 4ac. So in this first one, the a is 1, the b is negative 8, and the c is 17. So b squared minus 4ac, negative 8 squared minus 4 times 1 times 17, which is 64 minus 68, negative 4. So if the discriminant is less than 0, how many and what type of solutions do you expect? Do you expect real or imaginary? It's imaginary because you're taking the square root of the negative. And how many imaginary? 2. Plus or minus, right? You're going to get 1 for the plus, 1 for the minus. So we expect 2 imaginary. I mean, just look back at the graph, right? Less than 0, that was this one here. 2 imaginary, right? The next one, right? It's 1, negative 8, 16. This time it'll be negative 8 squared minus 4 times 1 times 16, which is 64 minus 64, which is 0. Okay? When the discriminant is 0, what do you expect? Right? Discriminant is 0. One real solution. I mean, you could memorize these things, but it ought to just kind of make sense, you know, with the quadratic formula, why that is. One real. And then the last one, it's 1, negative 8, and 15. So this time it'll be negative 8 squared minus 4 times 1 times 15. So this is 64 minus 60, which is 4. So if the discriminant is positive, which is here, what do we expect? 2 real. That's it. 2 real. So here's the last you try. Try the 4, 5, and 6. Calculate the discriminant and say how many and what kind of solution. So you can look up and see. That's what it should have worked out as. I'm rushing a little just because I want to start the quiz. Right, the first one should have had a discriminant of 48, 2 real. The second one should have had a discriminant of 0, 1 real. The last one should have been negative 271, 2 imaginary. If you're asked a question like that, don't calculate the whole quadratic formula. That tells me you don't know what the discriminant is. That would be a major faux pas, right? Just do the b squared minus 4ac. And the homework is actually written up here too. So if you want to, one way or the other, get it written down and we can start a quiz.